Welcome to Summarize Science, where we dive into the latest breakthroughs in technology. Have you ever tried to create a 3D model of something just by walking around it with your phone? Usually, AI generators struggle with these video streams because they treat every frame as a totally new image. This leads to 3D models that look glitchy or inconsistent because the AI forgets what it saw just a second ago. The researchers behind a new project called Stream 3D have found a clever way to solve this problem. They realized that instead of retraining an entire AI from scratch, they could simply add a smart memory layer on top of it. This system allows a frozen 3D generator to process long, continuous streams of video without getting overwhelmed. One of the biggest hurdles in 3D tech is memory management, as processing hundreds of frames usually requires massive computing power. However, the team developed a technique called adaptive evidential memory to keep things efficient. Instead of trying to store every pixel, the AI identifies which frames provide the most evidence for the object's shape. It calculates an evidence score for each part of the object to determine which views are the most reliable. As the video progresses, the memory updates itself, but it always stays the same compact size. This means that whether your video is 10 seconds or 10 minutes long, the AI won't slow down or crash. By focusing only on the most informative historical frames, the AI can maintain a consistent 3D structure. The researchers tested their method on both realistic and synthetic objects to see how it performed. In the visual comparisons, you can see that their method produces much cleaner details than previous versions. Other methods often lose the fine details or create weird ghost shapes where the AI gets confused. Stream 3D, however, keeps the geometry faithful to the original object by looking back at its best memories of the stream. Even when the camera moves in complex paths, the system stays locked on the correct 3D representation. This is a significant improvement over latent transport baselines, which often accumulate errors over time. They also found that deeper layers of the AI are actually better at understanding these 3D relationships. By selecting the top-ranked views, different parts of the 3D model can vote on which historical data to use. This ensures that even the backside of an object stays consistent even after the camera has moved to the front. To recap, this research is a major win for anyone who wants to create 3D content on the fly. They proved that AI doesn't need to be bigger or more expensive to have a better memory. By simply being selective about what it remembers, the AI creates more stable and realistic 3D worlds. In the future, this could change how robots navigate our homes by letting them build 3D maps in real time. It could also mean that creating high-quality 3D assets for video games will soon be as easy as taking a quick video. This breakthrough moves us one step closer to a world where our devices truly understand the 3D space around them. Thanks for watching Summarize Science, and stay tuned for more amazing tech updates.